Okay, this is the second video and we're talking about our road to trigonometry, and this video is all about angles. Now you guys may think that you know everything there is about angles, but there's a couple of things that you may learn in this video that you never thought of before. First, what is an angle? An angle is the measure of an angle, is a measurement between two intersecting lines, line segments, or rays. Pretty simple. So you could have an angle formed by two intersecting lines. Actually got four angles here, 1, 2, 3, and 4. You could have a ray going this way, a ray going this way, and there's your angle right there. So there's a whole bunch of ways to have an angle, but the important thing that with any angle you have what's called the initial side and the terminal side. So for example, on this angle right here, if we're going to measure the angle starting here and ending here, then this first is called the initial side and this other side is called the terminal side. Now terminal means the end, so it's where the angle ends. Now obviously I could draw the angle in a different way. If I grab a different color here, I could start the angle here and end the angle here, and the arrow shows me that direction. So if that was the case, then the terminal side and the initial side would switch around. Regardless of that, there are three ways to measure an angle. We can measure an angle in degrees, which everybody should be fairly familiar with. We can measure an angle in simply talking about how it's rotated around a circle. That should be pretty easy, but we'll recap that. And the last is this new way to measure angles called radians, and we're going to spend a lot of time in this video talking about that. Let's first, though, do a quick recap of how to measure angles in degrees. This is pretty basic. We all know that one full circle has 360 degrees in it, meaning that 1 degree represents 1/360th of a circle. So if we take an entire circle and we think of it as 360 degrees, that means that every 1 degree is 1/360th rotations around that circle. Now, most angles that we use in this class, actually I'll rephrase that, all angles that we use in this class are considered to be in standard position. Standard position puts the vertex right smack dab in the middle at 0, 0 of our XY axis. The initial side is always the positive x-axis. Always, always, always. The initial side is always the positive x-axis. And then we start rotating from there in a counterclockwise rotation. So for example, if here's my terminal side right there, then I started the angle here, I rotated that angle to end up right there. Now, we typically use Greek letters to represent angles in this class. Some of the most famous Greek letters are theta, which is basically a circle with a line through it. That's theta, T-H-E-T-A. We also have alpha, which is like our little fish kind of symbol. And we also have beta, which is like a B with a little longer tail on the front of the B. So there's other Greek letters, but those are the three we use most frequently. So my whole point is that I could label this as angle alpha, for example. Angle alpha looks to be a little bit bigger than 90 because obviously you guys know 90 is a right angle. This looks bigger than that, and maybe it's around 135 degrees. Again, just kind of spitballing it there. Now, we could also have angles that are considered negative. A negative angle, once again, starts off with our initial side here as the positive x-axis. That's always true no matter what. But a negative angle starts rotating down. So, for example, if here's my terminal side right here, if I rotate going in a clockwise direction, that would be a negative angle. There's nothing wrong with the negative angle. Negative angles are just angles that start in that initial side, the positive x-axis, and start rotating down in a clockwise direction. So maybe that is angle beta. It would be some negative angle. Again, maybe negative 30 degrees or negative 45 degrees, just somewhere in that neighborhood. So you get the idea of negative and positive angles measured in the standard position. Now here's a nice kind of big circle here to talk about as we're making these angles, and I put some lines here at some key places that we stop off. For example, this angle right here is 30 degrees. It ends right here, 30 degrees. This is 45 degrees. 60 degrees, and then everybody understands 90 degrees is right here. Now remember, we always have our vertex right smack dab in the middle, and our initial side is always going to be that positive x-axis. So again, you could see the 30, 45, 60, and 90 degrees there. Now, please be aware that we could also measure angles going in that negative direction. So if I were to go in this negative direction going this way, that puts this at negative 30 degrees. And then this one would be negative 45 degrees, and then this angle down here would be negative 60 degrees, followed up by negative 90 degrees. Now the only difference there is the direction I start going to find those angles. Now these are the three kind of major positions here, 30, 45, 60, and 90. Or I guess 4, and that means, basically all other angles are increments of that. So we have 30, plus another 30 is 60, plus another 30 is 90, plus another 30 would be 120, plus another 30 would be 150, plus another 30 would be 180 degrees, 180 degrees being a straight line. We can continue on, by the way, going up another 30. That puts me at 210 degrees. Another 30 would be 240 degrees. Another 30 would be 270 degrees. Another 30 would be 300 degrees. Another 30 would be 330 degrees. And another 30 would bring me full circle, 360 degrees. Now, understand that, for example, look right here. If I go in a positive direction, I'm at 300 degrees. If I go in a negative direction, I'm at negative 60 degrees. These are what we call coterminal angles. They're two angles that end at the same place. One went all the way around in a positive way to get there. The other went in a negative direction, a little bit faster to get there, but they both end at that same terminal side. Hence, they're called coterminal angles. So let's write down that definition. After completing their full rotations based on the given angle, two angles are considered coterminal if they terminate in the same position. So their terminal sides coincide. So again, I'm going to draw you a quick example here. Remember, we always start at that vertex at 0, 0. Here's my initial side, and I'm going to draw this angle right here, and I'm going to call that a positive angle, beta. Now, a coterminal angle could be another angle that actually there's several different ways you can find coterminal angles, which we're about to find out. But one way is to just go to that same exact terminal side, but in a negative direction. So maybe we'll call that alpha. So notice that alpha and beta are different angles. One's negative, one's positive. The negative one is fairly large. The beta here is probably around 60 degrees. But regardless, they both end at that same terminal side. That's where they get the name coterminal angles. However, there's another way that we could also have coterminal angles. I could go in a positive direction, make one full rotation, and then keep going and end at that same terminal side. So technically, every single angle has an infinite number of coterminal angles if you just continue to loop around and around the circle. So all you have to do to find coterminal angles is add or subtract 360 degrees. Every time you go around a full loop around the circle, whether it be clockwise or counterclockwise, you come to what we call a coterminal angle. So all you got to do is add 360 degrees. Let me just do a very, very quick example here. Let's just say that beta is 72 degrees. So it was 72 degrees for me to go to here to here. If I take 72 degrees and add 360, I'm adding a full circle. What I'm doing is I get 432 degrees. So that's starting here, going all the way around one full circle, and then another 72 degrees to get that 432 degrees. So 432 degrees would be coterminal with 72. Likewise, I can do 72 minus 360, and I get negative 288. So if I want to go in a negative direction, I would have to start going negative all the way around, and that would be negative 288 degrees. Regardless, all three angles are considered coterminal because they end at the same spot. So let's do a couple examples here. All you have to do to find coterminal angles is add or subtract 360 degrees. So for example, 176, I could add or subtract 360 degrees to get my coterminal angle. So 176 plus 360 gives me a coterminal angle at 536 degrees. I could also take 176 and subtract 360 to get negative 184 degrees. Now, if I want to find more answers, all I got to do is keep adding and adding and adding and adding 360, or subtracting and subtracting 360, and you'll get more and more answers. Negative 45 degrees, once again, to find coterminal angles, just add or subtract 360. So I'm going to add 360, I'm going to subtract 360, and I get 315 degrees would be a positive coterminal angle, negative 405 degrees would be a negative coterminal angle, but once again I could keep adding and subtracting to get even more and more. 405, I could add 360, and if I add 360 I can get 765 degrees. But I could also take 405 and subtract 360. Now if I do that, 405 minus 360, I'm left with another positive coterminal angle, 45. So if I want to find a negative coterminal angle, I just have to simply keep subtracting 360. So let me subtract 360 again to get negative 315 degrees. So the idea is you can keep going around and around the circle and finding more and more coterminal angles depending if you want them to be positive or negative. And here's a nice little chart, a final kind of chart to show this. Now what I want to show in this chart is start talking about rotations. So we know that one full rotation is equal to 360 degrees. So one full rotation, ROT for rotation. Now, 180 degrees would obviously be a half of rotation. A half a rotation would be 180 degrees. Again, all I'm doing is using some common sense, dividing both of these by 2. So a half rotation would be 180 degrees. 90 degrees would be 1/4 rotation. Okay, 1/4 rotation would be 90 degrees. You could also just understand this from looking at the picture. Remember, if I go 90 degrees right here, that is a quarter of the way around the circle, 1/4 rotation. So again, what would 30 degrees be? Well, all you got to do is take 30 divided by 360. You're just trying to find the proportion of 360 that 30 is. So 30 degrees out of 360 would be 1/12 of a circle. 45 out of 360 would be 1/8 of a circle. 60 out of 360 would be 1/6 of a circle. And then, like I said, 90 out of 360 would be 1/4 of a circle. So to find rotations, all you got to do is take your degrees and divide by 360, because that's your conversion factor. You know that one rotation equals 360 degrees. So if you take your degrees and divide by 360, you'll get how many rotations it is. You could also be more rotations, right? For example, 405 divided by 360. 405 degrees is bigger than one full rotation, so it's actually 1.125 rotations. It's over one full rotation, right? You can even make that a fraction if you wanted to, and you get that that's 9/8 rotation. And obviously, since the top number is bigger than the bottom, you understand that it's bigger than one full rotation. Okay, now I want to start introducing you guys to radian measurement. But to understand radian measurement, I have to first explain to you arc length. Arc length is simply the length of the circle that is cut out by a particular angle. So in my picture here, notice that I have a circle of radius r, and I have an angle theta. Now, once I have that angle theta, again, starting at that initial side, the positive x-axis, what happens here is I get an arc that's cut out by that angle, and that arc this length s. So it's pretty simple to understand arc length. Now, I'll explain that one more time. I have a radius, and I swing it out theta degrees, or whatever it is there, and I get my length s there. That's the arc length. So first off, let's make sure you guys understand arc length, because you guys should all understand circumference. Circumference is 2 pi r. 2 pi times the radius. So the entire arc length of an entire circle is 2 pi r. So think about 360 degrees would produce an arc length of the circumference 2 pi r. So all the way around a circle, 360 degrees is 2 pi r. Alright, so let's move over here and actually talk a little bit more specifically about arc length. What I have here is two circles, one that has a radius of 2, and one, the bigger circle on the outside, has a radius of 3. Let's talk about this arc length right here, this first one of the smaller circle, radius 2 there. Now, let's think about that. That was made from 45 degrees. 45 degrees, so 45 out of 360 is 1/8 of a circle. 1/8 of a circle. That means that the arc length would be 1/8 of the circumference. So the circumference is 2 pi times 2, because that's the radius. That's 4 pi. So the arc length right here would simply be 1/8 of that circumference, because 45 degrees represents 1/8 of the 360 degrees in a circle. So 1/8 of that circumference would be the arc length. So once again, 1/8 times 4 pi means that the arc length is 1/2 pi. So 1/2 pi would be the length of that arc. Likewise, let's talk about the bigger circle. Now, here's the kicker. The bigger circle also represents 1/8 of the circle, right? It's a bigger circle. The entire circle gets bigger. But it doesn't change the fact that 45 degrees is 1/8 of a circle. So the only thing that does change is the circumference is bigger. The circumference is now 2 pi times 3. 2 pi times 3 is 6 pi. So now, the size of this arc length right here is going to be 1/8 of 6 pi. 1/8 of 6 pi reduces to 3/4 pi. So that arc length right there is considered 3/4 pi, because it's 1/8 of the circumference 6 pi. So hopefully you guys understand the connection between the angle and the radius and the arc length. The radius makes the circumference bigger, but regardless, 45 degrees is 1/8 of the circle. Now, this all brings us to helping us understand this idea of radians. Now, what is a radian? Now, this can be a little bit tricky. I'm going to do my best to explain. If you actually need more help, all you got to do is type in what is a radian, and you can find many more videos that might explain it better than me. But one radian is created when the length of your arc equals the length of your radius. Okay? When the length of your arc equals the length of your radius. So the blue here is the length of my arc. The typical letter we use for arc length is S. And the radius is what's here in red that we use R for radius. When the red, the length of the radius, is equal to the length of the arc, exactly equal, that is when you have what's called 1 radian. So what we do here is we have a way of measuring angles in radians, and that way of measuring angles in radians is using this formula right here. An angle in radians is its arc length S, that's the arc length, divided by its radius. Okay, and when the arc length and the radius are the same, you get 1 radian. For example, if the radius is 5, whenever you have the arc length of 5, you get 1 radian. Or if your arc length is 10 and your radius is 10, you also get 1 radian. And again, I could continue this on and on and on. If your radius is 3, whenever your arc length is 3, you get 1 radian. So this formula is really, really important to understand to find radians. 1 radian is created when your arc length equals your radius. So what this does is this allows us to measure angles in a unique way relating the arc length to the radius. So a radian is the arc length divided by the radius. That's how you find radians. 1 radian is when the arc length is equal to the radius. Okay? So how many radians are in a full circle? Well, this is actually really, really easy to understand. In a full circle, we know that there are 360 degrees. Everybody understands that. Well, what's the circumference of a full circle? Because remember, radians is equal to arc length divided by radius. So the arc length of a full, complete circle is that circle's radius. I'm sorry. That circle's circumference. The arc length of an entire circle is its circumference. So 2 pi times r. Now, radians are created by taking arc length and dividing by radius, so arc length divided by radius. Now, what's unique here is that no matter what your radius is, it's going to cancel out. Whether your radius is 3, 5, 10, 20, doesn't matter, the radiuses will cancel out. So you automatically get that there are 2 pi radians in every circle. So 360 degrees equals 2 pi radians. Okay, we know that 360 degrees is the exact same thing as 2 pi radians. So in a full circle, we have approximately, again, 2 pi is approximately, if you actually use your calculator, 2 times pi is approximately 6.28. So there's approximately 6.28 radians in a circle. So no matter the size of the circle, because obviously smaller circles have smaller radiuses, they also have smaller circumferences. That's why the r's cancels, because the radius is directly related to the circumference. So an arc length divided by radius is your radians. So keep this formula. This is the formula you really want to keep in mind. Arc length divided by radius is how you find radians. Okay? Just keep in mind that when you have an arc length that's equal to your radius, you have exactly 1 radian. Alright, so if we use this idea, let's make sure we can understand some simple connections here between rotations, degrees, and radians. 1 rotation is equal to 360 degrees. 360 degrees is equal to 2 pi radians. Hopefully that makes sense to you. If it's not, you might want to go back and watch what I just did above. So let's talk about 1/2 rotation. 1/2 rotation would be 180 degrees, and half of 2 pi would be pi radians. So all I'm doing is cutting everything in half, right? So let's talk about 1/4 of a rotation. 1/4 of a rotation is 90 degrees, because 1/4 of 360 is 90 degrees, and 1/4 of 2 pi would be pi over 2 radians. Okay, so if I were to think about my circle again here, we all know that right here is 90 degrees, right? Right here is 90 degrees. Well, 90 degrees is also a quarter of a circle, and 90 degrees is also pi over 2 radians. So hopefully that all makes sense. And I can continue to do this. For example, 1/6 of a circle. 1/6 of a circle would be 360 divided by 6. That is 60 degrees. So 2 pi divided by 6 would be pi over 3 radians. So 60 degrees is equal to pi over 3 radians. Now, The key question a lot of kids want to know is how to convert between radians and degrees. And all you have to remember is this simple idea. 2 pi radians is 360 degrees. Now, if I divide both sides by 2 pi, I get that 1 radian equals 180 degrees over pi. Again, if I divide both sides by 2 pi divided by 2 pi is 1 radian. 360 divided by 2 pi, well, the 360 and the 2 reduces to 180 over pi. Likewise, I'm going to grab a different color here. Likewise, if I divide both sides by 360, I get that 1 degree equals pi over 180 degrees. All right, so all I did was I used this equation that I know for sure to be true 2 ways. I divided everything by 2 pi, giving me that 1 radian is 180 over pi degrees. So if you actually want to figure it out, take 180 degrees and divide it by pi, and you get that 1 radian is about 57.30 degrees. All I did was take 180 and divide it by pi. All right, so to convert from radians to degrees, if I'm in radians and I want to convert by degrees, all you have to do is multiply. And you have to multiply by 180 over pi. This is what we call a conversion factor. 180 degrees is equal to pi radians. So to convert from radians to degrees, all you have to do is multiply by 180 over pi. To convert from degrees to radians, you want to multiply by the reciprocal of that, pi over 180 degrees. All we're doing is multiplying by a conversion factor. If we're in radians, well, every one of those radians is worth 180 degrees over pi. So that's why we multiply by 180 over pi. If you're in degrees, every 1 degree is worth pi over 180 radians. That's why we multiply by that. So very, very simple. So here's 2 simple examples to end the video with. 127 degrees, if I want to convert. The first thing is I want the 180 on the bottom. One way to remember that is that you want the degrees to cancel out. So that's why we want the pi radians on top. So to get this answer, I want pi in my answer, because the moment you type in pi in your calculator, you're going to get an irrational number. So I want to leave pi in my answer. So all I'm going to do is take 127 divided by 180 and reduce that fraction. It's 127 over 180. It doesn't reduce. So that's really, really easy to understand. So 127 degrees is 127 over 180 pi radians. Okay, if I want to convert 7/3 pi radians to degrees, what I'm going to do here is this time I'm going to put the pi radians on the bottom and the 180 degrees on top. One way to remember that is that the radians cancel. That's why I want them across from each other. Now, what's also going to happen is that my pi's cancel, so all I got to do is figure out what is 7/3 of 180. 7/3 of 180 is 420 degrees. So 7/3 pi is equal to 420 degrees. Okay? So I'm going to go all the way back to, let's see here, I want to go back to this chart here to end things to show you this. Now, we know that all the way around a circle is 306 degrees, or 2 pi radians. That means 180 degrees is pi radians. Okay? Remember, I'm just using my conversion factor, the fact that 360 equals 2 pi radians. And we just put RAD for radians. So once again, 90 is 1/4 of a circle. So 1/4 of 2 pi is pi over 2 radians. So 90 degrees would be pi over 2 radians. 30 is 1/12 of a circle. So 1/12 of 2 pi is pi over 6. So 30 degrees is pi over 6 radians. So it's pretty easy. As long as you understand the connection between the 3 things, it should make finding the connection hopefully very simple. So once again, let's do one more. 45 degrees is 1/8 of a circle, so 1/8 of 2 pi is pi over 4 radians. Again, all I'm doing is taking 1/8 of 2 pi, which reduces to pi over 4 radians. All right, that's it. Hopefully you understand radians a little bit. Definitely answer some questions in class.